So I am the advocate for low Earth orbit. And full screen mode. Okay, so I believe that the first place that will be settled outside of Earth will be equatorial low Earth orbit, which is orbits, we all know what low Earth orbits are. Equatorial simply means very low inclination, under 5 degrees. And the first evidence that I will present for this is what has happened. So stations are the closest approximations of settlements we have. We've had stations in low Earth orbit for 30 or 40 or 50 years. And we have one up there, and it's working right now. We have no bases on the moon. We have no bases on the Mars. And I think that's very simple. They're really far away. Low Earth orbit is a couple hundred kilometers, 400, 500, 600 kilometers. The moon is 384,000 kilometers, and the Mars is much more difficult. And as anybody knows that has run a supply line, distance is expensive. However, the settlements that have been designed for settlements, ones from done in the 70s by Gerard O'Neill and his buddies, they haven't gotten built either, right? And why is that? Well, I think it's just simply been too hard. First of all, they're too far away. Stanford Torus was designed to be at L4 or L5, which is lunar distances, so you get no advantage in distance. They're too massive. They weigh millions of tons because the radiation shielding is absolutely necessary. And if you're going to Mars and back, you can just absorb the radiation. You probably get away with it. But you can't go up there and live for 30 or 40 or 50 years and get a half a secret a year. So you have millions of tons of radiation shielding. It's very difficult to live. They're too big. They're kilometer scale. When we started building bridges, we didn't start with the Golden Gate Bridge. We started something over the local creek. And there's no incremental path. There's no way you can get some income or maybe even profit on the way. And the net result has been no settlements. So, what do we get out of ELEO? Well, first, it's very close, 500, 600 kilometers away. You can plug right into the Earth's economy. The only transportation you need is a launcher, which is going great guns just now, and you can get an incremental path of ever increasingly large hotels until a hotel's about the size of your settlement. You build a couple, you get good at it, you rotate faster. And the key that makes all this work is if you put it in very close to the equator, there's not that much radiation, which I discovered by using Alteris. NASA's front end is some Air Force radiation codes. And there's so little radiation that in some of the really sweet spots, you may be able to get away without any radiation shielding whatsoever, and that makes it launchable. Okay? The other thing is you can make it small by rotating fast. People think, oh, if you rotate more than 1 RPM, you'll get sick. That's true, you will get sick at 4 RPM, say. But you'll get better in a couple of hours, a couple of days if you're particularly susceptible. It is an irritation, not a stopper to settlement. So if you rotate at 4 RPM, you have a system that's a diameter of 112 meters, which probably is too small. But the whole point is to get this thing down as small as you can is acceptable. Now, if you play these two tricks and you accept the most optimistic rumors about the price of launch with the super heavy distortion, and if you're not an optimist, get out of the space settlement business. Okay? Thanks so much.
Way below.
What?
Starship costs are way
Way
below.
below.
What do you have?
Oh.
1.2 million.
Oh, 1.2 million. 1.2 million is sufficient. The idea is that's enough to launch your share of the stuff that makes it settlement, and yourself. So it's not 1 kilogram or anything, or a ton or anything like that.
One person.
Yeah. Yeah. I'm assuming 100,000 for these numbers, but yeah, might as well be the same. So it looks like you get the transportation cost to get you and the stuff, your share of the stuff up there is about 1.2 million. And if you put all this together, you got some. The thing I want to point out here is here's the characteristic numbers, the mass, the size, all that, the number of people. And here's the ISS. We know we can build that because we did. Here's Colony 2, which is designed with those ideas in mind. And you'll notice this, they're bigger numbers, but they're kind of in the range. And then there's the Stanford Torus, and look at all those zeros. That's why it's the zeros why Stanford Torus hasn't been built. It makes it too difficult. So preliminary financial sketch. If you believe that $1.2 million is true, then you might even believe that you can, and I don't have time for the analysis, but that for $5 million, a couple could move in, including the stuff and putting the stuff together. If you use a real estate model, you say, okay, I'm going to buy a condo on this new development that happens to be in low Earth orbit, and it's going to cost me $5 million. So I'm going to take $1 million that I made in my really, really good job, and I'm going to borrow $4 million in the mortgage, and lo and behold, I can move in. So the problem of making this happen boils down to how do you make $4 million? How do you pay your $4 million mortgage? And the answer is A, there's no delay. You can be fully integrated into the economy. This isn't going to happen for a couple of decades. Easy. By then, the communication system of Earth is going to be just awesome beyond any imaginable belief. And so you just keep your job. This one that made you $1 million, you use that to about $4 million. The second thing you can do is any large satellites won't fit under a fairing. You can have them shipped up in parts. The locals can put them together and they send them off. This is really great for space solar power. If you're building space solar power, you would not start by building Component 2. You just build space solar power satellites. But if Component 2 existed already, and all you had to do was hire the people and lease their facilities, you'd be fool not to use it. Thank you very much.
All right, thank you, Al. We didn't exactly define the amount of time, so we're going to have each person make a statement for his preferred where to start first. We started with Al with the closest in place for space settlements, and now we're going to the farthest, well, sort of, asteroids are
Do
everywhere.
we collect the votes?
Yes, so Doug would like to collect your votes.
So before hearing Al, what was your opinion about where we're going to settle first? Green is Earth orbit, blue is Moon, orange is Mars, and yellow is asteroids. So go ahead and please just pass it towards the center right now. This is the first vote. With your second pack, we'll vote again at the end after you hear everybody, okay?
They're voting for after they heard Al.
Yes.
That's good.
All right, so our next speaker is very esteemed Dr. Bob Zubrin, talking about Mars. And please know, right? Does everybody know who this guy is? Yeah, okay, good. I mean, they're famous. All right, let's go. We're not going to.
All right, an astronautical engineer and president of the Mars Society, and author of some books, including most recently, The Case for Space, which you should have bought yesterday because they sold out. But we still get it on here. All right, so the topic of this debate is where should we settle first, not where NASA's next major initiative should be or anything of that sort. What should be our major target for actual space settlement. And so I'm going to argue for Mars. And the reason why is that Mars is the closest place that has all the materials needed to support life and therefore technological civilization. And if we can go to Mars and learn how to transform these materials into resources, because by the way, there's no resources available anywhere. There's no such thing as a natural resource. Any natural raw materials. It is human creativity that turns raw materials into resources. There were no natural resources on the Earth until people figured out how to take materials. Land was not a resource until we invented agriculture. Oil was not a resource until we developed oil drilling and refining and machines that could use the product. Uranium was not a resource until we developed nuclear fission. Deuterium is not a resource now, but it will be if we develop nuclear fusion and so forth. And there are no resources to be found on Mars, the asteroids, or the Moon until there are resourceful people there. Okay. But that said, there's more materials to work with on Mars. Okay. For example, of course, water. Now, it has now been shown that there is water to be found in permanently shadowed craters near the lunar south pole. Okay, now that's important. Okay, but there are much vaster supplies of water on Mars, gigantic supplies of water, and not just in a few permanently shadowed craters in an exotic place that is difficult to get to, but all over the place. In fact, recently we have found glaciers on Mars as far of pure water ice as far south as 38 degrees north, which is about where you are right now. San Francisco, Athens on Earth, 38 degrees north. So there's ice available in mid-latitudes, there's subsurface water, there's probably geothermal heat on Mars. Okay, the big volcanoes on Mars, they're a few 100 million years old. That may seem like ancient history, but that's only a few percent, 5% of the age of the planet. If they could make volcanoes then, they can make them now. There's underground heat, which is why they have discovered liquid water on Mars. It's hot down here, and that's why there's methane emissions on Mars. Now, of course, the second resource available on Mars is carbon dioxide. It is 95% of the Martian atmosphere. Now, we are carbon-based life forms. Okay, we are made of carbon and water. Everything we eat is made of carbon and water. Everything we wear is made of carbon. Everything we use is either made of carbon or made with the help of carbon. Carbon is absolutely essential. It is absent on the moon. Okay, that's a real problem with lunar zone. Okay, now nitrogen. That's the fourth key element of life. It is the minority constituent of Mars's atmosphere. It is absent on the moon and is absent on asteroids. Okay, now by the way, all this stuff is absent in Earth orbit because there is nothing there. Okay, there's no there. Okay, now, so I should say that. So the moon is very, it's abundance compared to Earth orbit. Okay, as poor as it is. Mars has got a 24-hour day, which is nearly identical to what we have on Earth. This is tremendously advantageous both for people and for greenhouse agriculture and for any number of other activities. Mars's atmosphere, as thin as it is, okay, is thick enough to mask out solar flares. That's very important. Okay, that is, if you are on the surface of Mars and you're looking up towards the zenith, there's 16 grams per square centimeter of mass between you and the top of the sky, okay, which is comparable to the thickness of a solar flare storm shelter that we put on a spacecraft. However, if you average over the 2 pi steradians, the full hemisphere above you, because the solar flare is coming in from every which way, it's coming into the atmosphere at a slant, it's 65 grams per square centimeter, equivalent to 2 feet of water between you and the solar flare. That's plenty shielded. And what that means is that plants can be grown on the surface of Mars in thin-walled greenhouses using natural sunlight. That is an extraordinary advantage over locations where you have to use underground greenhouses or thick glass, 5 inches thick, okay, like you would on the surface of the moon or in free space. Because trying to grow plants with electricity is very difficult. If you know, Rhode Island is not ordinarily considered one of the world's agricultural giants. There are some farms there if you go there. But you couldn't feed the earth with the agricultural production of Rhode Island. Okay. However, to illuminate Rhode Island with natural sunlight would require all the electricity produced in the world. Okay, so this is why plants are ordinarily grown outside. I mean, I am skeptical of solar energy for powering industrial civilization, but it really works great for outdoor lighting in the daytime and and for growing plants. Okay, Mars has had a complex geologic history, okay, with water action and volcanism, and this is what is necessary to produce mineral ores. Okay, you can take, I mean, copper is actually a geochemically rare element. There's no more copper on Earth than there is neodymium, okay, but there are natural processes that have concentrated copper to the point that Neolithic civilizations were able to make use of copper as our first metal. So it's been used by people. The American Indians used copper, some tribes, and of course ancient Egyptians and so on, and so forth. This has occurred on Mars. It has not occurred on the moon. It has not occurred on the asteroids. Okay, so because it is so much richer, Mars compares to the moon for the coming age of space settlement as the North America compared to Greenland in the previous age of European maritime expansion. Because Europeans reached Greenland first, closer to Europe, but it was simply a much more impoverished environment. It was not one where people could actually establish it. They could establish an outpost, and they did, but not a full, vibrant, growing branch of human civilization. And this is why Mars should be the target. And then, of course, now the objection that is brought up is exports. What are you going to export to Earth? Okay. I maintain that the chief export of any space colony to Earth will be that which is easiest to transport, which is to say information, not materials. Okay. Because of the enormous cost of space transport. What is the most valuable kind of information? Inventions, patents. That is the most valuable information per bit that you can possibly generate. You can have billions of dollars worth of value associated with a megabit of information that comes at a patent. Okay, Mars colonists, what are they going to be? They're going to be a group of technologically adept people in a frontier environment where they're going to be forced to innovate and will necessarily be free to innovate. There's going to be a tremendous labor shortage. They're going to need to resolve it with labor-saving machinery, robotics, artificial intelligence. Even with greenhouse agriculture, it will be much more limited compared to the open fields of Earth. So they will push genetic engineering to the limit to get ultra-productive crops. Okay, the deuterium is actually 6 times more abundant on Mars than it is on Earth. Now, the deuterium is so valuable that one might conceivably send it to Earth. But more importantly, this is a tremendous driver to develop fusion power. On Earth, it hasn't been such a driver. You got waterfalls, you got fossil fuels, you can do this, you can do that, a kilowatt's a kilowatt. Okay, but on Mars, solar energy is weak. You can make fossil fuels out of carbon dioxide and water, but it takes energy to do it, and so there's no gain to be had there. Okay, there won't be waterfalls on Mars until we terraform the planet. But you get the point. These inventions that the Martians made for their own progress and prosperity will be licensed on Earth. That'll be their exports, and that's how the new world will progress, through creativity. Martian ingenuity will save Mars and will save you.
Next speaker is Rhonda, who's probably not going to know. I'll let you self-introduce.
Sure. Yeah, my name is Dr. Claude. I'm an urgent care physician in Redlands, California, Southern California. I'm going to be arguing that Moon is the logical place where it is going to start settlement. Just pulled up. Just as this is coming up, let me just say in the slides that I'm showing, I'm not actually showing asteroids. I'm not comparing with asteroids because I don't know enough about asteroid settlement to really make clear arguments. It's just not clear to me, and apparently not to you guys as well, as to why asteroids would be the first settlement. So I'm going to go ahead and compare it with Leo and also Mars. Okay, so where first I'm saying, well, before I get into it, let me just sort of make a point. The question here is not where is the ultimate settlement, where is the civilization. The question here is where is the first settlement. That's the question. Okay, so what I'd like to point out is what is the difference between a base and a settlement? If you have a base, you've got habitat systems, you've got life support systems, you could have food grown in the base, you've got radiation shielding, okay? What about an initial settlement, okay? And what is settlement? Settlement is when somebody sells their home on Earth and they move as part of the family, and the easiest, simplest first families are couples, and so like retirees, for example. What do they need to settle down? Because that is the root of what settlement is. What do they need? They need habitats, they need radiation shielding, they need power systems, they need to be growing food. It's the same thing, but the people going there, if they're going to settle down, if they're moving, if they're establishing a home, that's what defines settlement. Settlement starts small. Settlement starts with a few people and then grows on from there into a larger settlement. And there's also different types of settlements. Not all settlements have to have children. Retirement settlement could be the first settlement, and I think it will be. as I'll explain. So what's the difference between a base and settlement? It's the reason why people are settling down, okay? Who will be the first settlers? These are the people who are like paying tickets to SpaceX to move to the moon or move to Mars, okay? These are people who have had to have lived long enough to be able to afford to buy the tickets, okay? You gotta pay the ticket if this is a private settlement. They gotta be free from child rearing responsibilities, okay? And they've got to be free from occupational responsibilities unless it's consulting or doing this digital sort of stuff. Who are these people? They're retirees. Retirees are going to be highly overrepresented in the first settlements, okay? This is important. It's very important when it comes to Mars, actually, okay? So here's a diagram. Here's Earth. Here's Earth orbit, like equatorial Leo, and here's the moon. Ignore the scale, okay? So the point is that it costs less, it makes sense, it costs less to go ahead and deliver payload to Leo, okay? And if you run it through the rocket equation, you only get about 25% or thereabouts of the payload to the lunar surface. You've got to burn propellant to get the payload there, okay? So normally it would look like it'd be more expensive to go ahead and get stuff on the moon, okay? But if that stuff is a spare part that keeps telerobots working at a ratio of about 1 to 10, a motor that needs to be replaced to keep the telerobot going, then that telerobot of 10 times the mass could produce 10 times of its mass a product from local resources, whether that's water, metals, whatnot, before another repair needs to be sent. So 1 unit of mass can result in 100 units of material, and that's because resources matter. Material resources really matter. In the case of Moon and Mars, that's a distinct advantage over a place where you've got to launch everything, or you've got to develop a system to bring it in from asteroids. That's another possibility, okay? Percent mass independence. I have been running a track here, and we're looking at exactly how can you become increasingly or potentially entirely mass independent or Earth independent. So here's an example or just illustration of if you get your descent propellant, you reduce your mass by about 45%. If you can do these other ISRUs, you keep reducing the amount of mass that you need to depart from Leo, okay? If you can get these 4 things produced locally, and we know where they are on the Moon and Mars, and asteroids, if you can produce these, then fairly early on, you are knocking off the big masses. And so this is a realistic sort of thing. Roughly 85% relatively early on. We're talking the early years of a base, okay? Here's another point I'd like to make. Travel time. Think about it. Elon Musk has Starship, which he's designing for Mars, okay? That Starship would be used every synodic period, every 26 months, okay? How many times could that ship be used to go to the moon and back? Let's say it takes 2 weeks to go back in turnaround time. You could sell, what is it, about 56 tickets to the moon for every ticket that you sell for people going to Mars. So I think that, even Elon says that there's going to be a base established on the moon first before it's established on Mars. I don't know if you guys know that, but that's what he has said, and I agree with it. Finally, I'd like to make a point about the grandkids. I think this is not a small factor when it comes to Mars, and that is to be telepresent at your grandkids' graduation or wedding or whatnot. That's possible from low Earth orbit and also from the moon. You can communicate, but it's more like sending video messages to Mars. So remember, it's that intersection of who can afford to go and who wants to go. On the want to go side of thing, I think grandparents, the retirees, are going to think twice before they make that much of a disconnect from their family. And so I think that Leo and the moon have the advantage there. So I would like to, this is just my ideas. Green is good, yellow is some question, and red is problematic. I think when comparing Leo and the moon, the construction cost, the cost to actually produce the structures and also to support. It's always got to be launched to LEO, but it can be produced on the moon. So I think that's a significant factor. Resources, Moon and Mars are definitely advantageous there, and I would agree Mars has better resources, but with telerobotic reach, I think we can go ahead and develop the resources on the moon. And let me just say that L-cross results, we got nitrogen in the form of ammonia, we got the signature, the spectroscopic signature of that, and we know approximately what percent. Carbon is in the form of carbon monoxide, methane, and what's that? Ethylene, okay. We got carbon, nitrogen. If you recycle, and if you're producing quantities of water from the lunar ice, you'll have more than enough of those things for what you need. And then international interest, we know that there's a lot of interest in the nations in exploring the moon. I believe more so than going to a commercial station. And that interim phase, that international lunar exploration phase, is going to be a critical phase to be able to lower the cost and to develop the ISRU so that settlement just follows that quite naturally. And then comparing the moon with Mars, Mars has quite a number of problems. Travel time is a real problem that people will have to think twice about if they want to spend that much time to go to Mars. The moon is 3 days away, and obviously Leo is a day away. Teleoperations is advantageous. You can have a large workforce on the moon through teleoperations. The grandchildren I mentioned, transportation cost is that 56 times more tickets that you can sell to go to the moon. Tourism is, you can go on a vacation on the moon because it's a short period of time. To tour Mars, you got to give up a portion of your life to do that. I don't see tourism, short-term tourism occurring on Mars. And then retirement is the grandkids. And so with that, I want to thank you for your attention.
Our final location advocate is Joel Sercel, and I love the shirt. Joel is wearing his advocacy for asteroids.
Well, it's true that I'm an advocate for asteroids, but not for a place for human beings to settle first. That would be ridiculous. This is the one I want. So before I start, let me tell you a little bit about myself. Joel Sercel. I'm the CEO of Transastra Corporation. Transastra is a company dedicated to developing the technologies and systems for space resource utilization. And Transastra has won many NASA grants and contracts, and is partially funded by NASA and partially by private sector investments. There'll be some announcements about investments in Transastra next week. I'm also the CTO of Momentous, which is a startup in Silicon Valley, which publicly admits to having raised $9 million. It's actually much more than that. Our first launch is in July. And we're building space plasma rockets that use water as propellant for delivering payloads from where rockets leave them off to where they need to go in space. My PhD was from Caltech in plasma propulsion and spacecraft engineering. I taught at Caltech for 12 years. I was at JPL for 14 years, conceived of the NSTAR project, which led to the Deep Space One mission and the Dawn mission to Vesta and Ceres. So that's a little bit about me. If you want to know about the resources of the asteroids, I have many lectures online, and it's a longer subject than we have time to talk about today. I'm not here to advocate that human beings should settle the asteroids anytime soon, but I do believe that the asteroids are the most important resource for humanity for our long-term future. And like Gerard O'Neill, I believe, and like Gerard O'Neill and Jeff Bezos, I'm convinced that deep space is the long-term residency of humanity's progeny. Because in deep space, we can create artificial gravity through spin, we can create Earth-like environments with radiation shielding from the asteroids, and there's enough asteroid material to build beautiful worlds with a carrying capacity of 1,000 times that of the Earth, 1 trillion people, and 1,000 years of future for humanity. But I don't know where we should settle first. And a wise man once said, "A closed mind gathers no wisdom." And so I spend a lot of time trying to develop a modicum of wisdom by listening as hard as I can and asking questions, and always being willing to change my position on the basis of what I've learned. So, we're going into space for the betterment of humanity. Space is a different location from the Earth. So there must be something about the location of space that's beneficial. And so if we're going to talk about where to go first, we have to ask, what is it about that location in space that provides benefit? So the first thing is to be economic, and the key is, if it's not economically self-sustaining, it's probably not going to last. It's almost certainly not going to last. That's the legacy of Apollo. So to be economically self-sustaining, it has to benefit the Earth. So if we're talking about where to go, there must be something about that location that provides benefit to the Earth. It has to be a safe place for humans to live. It has to be as easily accessible as possible to and from the Earth. And it should have resources that ultimately can benefit the Earth. So these are just axiomatic, simple requirements that any rational person would consider deciding where to go. So let's think about now where to go. So one possibility is the high inclination low Earth orbits that have been used for space stations up until now. The beauty of these is that they have relatively easy access from Earth. They do have moderate radiation, so human beings can live there for moderate periods of time of up to a year or so. There's no way that multi-generational people can live there unless they have 20 feet or so of radiation shielding, and it's not ever going to be affordable to launch that from the Earth. Later on, that radiation shielding can come very affordably from the asteroids, but it's not cost effective to bring it to low Earth orbit from the asteroids. Here's an important point for industrialists to remember, and I know some industrialists have been thinking very carefully about this. If you're going to build a space hotel, the view of the Earth is a very important factor. And high inclination orbits, like the space station orbits, give beautiful views of the Earth, and the astronauts spend every waking moment that they have free time staring at the Earth. That's going to be a huge tourist attraction. So it would be a great place for a hotel, and we know it's a good place for a research lab. The most important research that should probably be done in such a place is the effects of variable gravity and microgravity on long-term human habitation. Equatorial orbit, I completely agree with Al Globus. He has made a compelling case that the most important first industrial location in space for human beings is equatorial low Earth orbit. Once we get launch sites and landing sites on the equator, it's a lower delta V to launch, and it's lower delta V from equatorial Leo to Geo, the moon, and many other places. Unfortunately, it provides boring views of the ocean all the time, so it's not a great place for a space hotel. But the radiation safety without shielding is a massive benefit. That's a big, big deal. And we should all salute Al for recognizing that. That's innovation and genius, my friends. So as we start to build large engineering systems in space, if human beings can have a role in helping to build those systems, things like space solar power satellites, we can ship the materials up inexpensively from the Earth. This would be a great place to build a factory for space solar power satellites. And then, to be cost effective, we build a beautiful place to live, like what Al showed, and make that a settlement for the people who work in space. And I think that's a fantastic idea. Geo, there's a lot of good commercial reasons to be in Geo. It's not real good from the delta V perspective, but it's not real bad either. For long-term habitation, you need heavy radiation shielding. So I would say it's a great place to put robotic factories. High cislunar orbit could be L4, L5, L2, and there are other orbits like that. And Gerard O'Neill was a genius, and he was right. There's tremendous benefits to high cislunar orbit. It has easy access to the radiation shielding virtually infinite amounts of radiation shielding available from the asteroids. A really compelling advantage of anywhere in cislunar space is the relatively short trip time. You know, Jamestown died because of a lack of access back to the continent. And stuff happens when you're making an early settlement. And if you've got to wait years for rescue, don't sell insurance to those settlers. But it's ideal for O'Neill settlements. Now, what's really compelling is the way manufacturing technology and robotics are coming. And we can envision massive, large-scale, additive manufacturing, 3D printing of geostructures coming very quickly, eating asteroids and turning them into O'Neill colonies. So this is a compelling place to live. So if you're going to vote for asteroids, you vote for this. But I don't think this is the first place we're going to settle, but it's a compelling long-term location. The moon's surface. The problem with the moon is low gravity. We don't have a scintilla of evidence that multi-generational humans can live in anything but 1G. There's an abundance of theoretical biological information that says the following. If you evolved in a 1G environment for the past few billion years, you're not going to do well in microgravity or in reduced gravity. That's a real killer for long-term habitation on the moon. Once we get genetic engineering and we're no longer really human, maybe transhumans, that could be an option. The beauty of the moon's surface is short trip time, and I should have said the ice resources are very valuable, and there are some other, and the peaks of eternal light where you get nearly constant solar power vary. So I would say it's great for short stay hotels. I'm convinced that Blue Origin will have a short stay hotel on the moon within 15 years. And great for science outposts, like the International Space Station, sort of governmental things, maybe augmented with industrial sponsorship. Mars, spin gravity, not practical, real problem. There's no scientific evidence you can live on Mars. Perchlorates, 0.5% by mass, perchlorates pervade the entire planet. Perchlorates make your thyroid stop working. It's a poison. The planet is poison. Any Martian, now here's the thing. We don't know how much life there is in the universe. We only know about life here on Earth. If we find non-terrestrial life, something different than our DNA on Mars, and we go and propose to terraform Mars, we have now exterminated the life of another planet. If there is a higher intelligence in the universe, and has been monitoring us, that may be the one thing that deserves a death sentence for a civilization. So, any consideration of massive settlement on Mars before we understand Mars biology, if there is Mars biology, has to be put on hold. The trip time from Mars makes it impractical for families to live there or to sustain civilizations. And really, there's no possible exports of material from Mars that could make any economic sense. So it's great, however, it's great for short stay hotels and science outposts. As Jeff Bezos says, the best planet in the solar system by far is Earth. Once there's a Starbucks on Mars, I'd love to go there on vacation. And I think that makes perfect sense. But I'm not going to stay more than one trip because it's not safe. Remember, a successful space settlement will take advantage of we're going to space because we think it's a location that can help. Space is big. We have to pick the location that can help us economically as a people first. Now, it could be that pilgrims, basically people who have no interest in supporting Earth, for their own purpose, invest their own money and go to live on Mars. And my feeling is if they want to do that, that's fine. We should absolutely enable them to do that, to not get in their way. Not a penny of taxpayers' dollars for such a folly. So if you take these and you score the different options against benefits to Earth, safety, accessibility, and resources for export back to the Earth, you find that equatorial LEO makes the most sense in the short term, and in the long term, high cislunar habitats supported by asteroids. So phase one, early commercial expansion, a space hotel in high inclination low Earth orbit. Phase 2, new space industrialization, equatorial LEO settlement and factory, and a high cislunar depot to help with industrialization. Phase 3, mature industrialization and settlement. That's where we develop massive robots to print O'Neill colonies. And that's where we really get an umbilical to the solar system. And finally, in the long term, when human beings are genetically engineered and billions, trillions of people are spreading, people and other post-humans are spreading throughout the solar system, we'll have O'Neill colonies throughout the solar system, and genetically engineered people will live on Mars if we're sure that we're not going to destroy any Martian biosphere.
Okay, thank you. There's some impassioned statements for each of these locations. Thank you all. So what we're going to do next is Doug is going to have us do another vote on where now you think is the best location to have the first space settlement. And it was, let's see, green.
But green Earth orbit?
Yeah.
No one's advocating early settlement of asteroids. So treat that as high cislunar.
And then what I'm going to do is ask each of our panelists in the order they presented to have a 1-minute rebuttal that I will time, a 1-minute rebuttal to everyone else. And then we'll open it up for questions. And normally the session chair will have the first question. I'm guessing there are rules and questions out there, so I don't need that. So Al, I'm going to ask you to come up and do a 1-minute rebuttal.
Just throw the mic.
And as soon as you start talking, I start timing. All right, 1-minute rebuttal.
Okay, the first thing to recognize is I don't care where you put your settlement, you're going to need a transportation system to get stuff to it. Okay, there is no place that is everything you need, period. And the nice thing about the equatorial low Earth orbit is you only need one transportation system, which is a launcher, and it is getting worked on great gangbusters. There are like 100 companies working on it, and some of them doing really, really, really good work. And that's all getting done from the point of view of space settlement for free. Okay? So the fact that you don't have any materials, we just launch it from Earth. Obviously, that's not going to go on forever. Okay, then you eventually want to exploit the materials and things. But it vastly simplifies the system. You don't need to figure out, I mean, yes, once you can build habitat models on the moon, you get this big advantage. But you gotta, to do that, you have to know how to mine the moon. You don't have to process the materials into something that is useful. You have to know how to fabricate it. And that's a lot of work. And it's not going to happen in a couple of years.
Thank you. Okay. All right. 1-minute rebuttal to everyone else.
Okay, well, I can just say I'm glad that Joel was not around when the fish were debating whether they should leave the ocean. There wasn't one scintilla evidence that life can survive on land. And what are these life landforms going to do for us in the ocean anyway? Or more to the point, when human beings left Africa. Because, you know, human beings are not native to the earth. We're native to Kenya. Okay? We are tropical animals. That's why we have these long, thin arms with no fur on them. Okay? And we only survive on the rest of the earth, okay, because of development of technology like clothing, houses, fire, okay, methods of growing food or acquiring food in the wintertime, preserving it for long periods of time. And hey, look, it's the fish that did the most for the future are the ones that left the ocean. Okay, and I would argue the people that did the most for the future of human culture were the ones that decided to leave the kingdom with them. Okay, and you know, Europeans had colonies that were of more economic value to Europe than the American colonies. Okay, in fact, the reason why Cornwallis was captured at Yorktown is the British fleet was down there snatching sugar plantations in the Caribbean when they should have been rescuing him. Okay, and okay, well, time's up. Anyway, it is those who go forward that contribute the most, not those who stay behind.
Okay. Let me just specifically address the hypogravity, like 1/6 gravity on the moon and 3/8 on Mars. It is true that we don't really know the effects of that on gestation and childhood. But there is some data that would suggest that there's a problem there. I think that the health of children could be negatively affected at both of those locations. Exactly how much do we need? Do we need 0.7, 0.8? I think it's like a sedentary lifestyle. If you bought an Xbox for your kid, it's probably what's going to be like going to the moon or Mars.
It's like living in a wheelchair and bed rest for the rest of your life, at least.
Yeah, I'm not
No,
convinced
the
of that,
fact
but-
is there's no data. So you can argue that we don't have data to establish it. You can't argue we have data to disestablish it.
So what it is we need to get to the moon. We need to do the permanent base that they're planning. We need to have indoor centrifuge, and we need to use that for adult health, for the crew's health. And while we're not using it, we need to use it for a series of animal studies. And it's a pretty straightforward set of animals that we would use. And if it turns out we need full G 24/7, then I become an O'Neill.
Okay.
So the advocates of Moon and Mars admit that we have no data to prove it's safe, and yet they advocate billion-dollar investments in going there and settling there, so that people can die in agony and their children can be stillborn. So when the fish walked up on the land, Bob is advocating that they should have settled in volcanoes. Okay? It is irrational to advocate for something that there's no evidence to prove that it's survivable. So Mars is a wonderful romantic fantasy from the 1950s, and it was great in 1950s science fiction movies, and that's where it needs to stay. Seriously, we're scientists and engineers. We're not science fiction writers. We've got to be serious. When the fish walked up on the land, they didn't just go anywhere. They lived where fish could survive on the land. And we will do that in space.
All right, we have 10 minutes for questions from the audience. We got one back there.
This question is for Al. Al, how do you think spaceport in equatorial location can help your dreams of your project for that infrastructure, for creating that infrastructure?
Because there's a region of low radiation there. That's an area that gets the most protection from the Earth's magnetic field. And I've done the calculations using Alteris with good models for bad radiation here. And at 500 kilometers directly over the equator, you might not need any radiation shielding at all.
That's incredibly important.
So it saves you millions of tons in your system, makes it a lot easier to build.
This is new data that the space community needs to sit up and take notice of. This can be our beachhead into the solar system.
I challenge the veracity of it. The Earth's magnetic field is not strong enough to block out galactic cosmic rays. And so the reason why the radiation dose at the space station is half that of interplanetary space is because the Earth is blocking out half of the sky. Okay, the Earth's magnetic field is not blocking out the cosmic rays. And we've also found this on Mars. The cosmic radiation dose on the surface of Mars is half of that in interplanetary space for the exact same reason. Okay, certainly you can be free of the trapped radiation in certain Earth orbits. That is an advantage, but not cosmic rays.
That's not true. Cosmic rays, it's true for some cosmic. The heavy, iron nuclei moving at relativistic speed, absolutely true. Absolutely true. However, cosmic rays consist of a wide variety of energies, mostly protons actually, not iron nuclei. And I've done the calculations with the models, and anybody who's a legal resident in the United States can get an account in Alteris and go and do the calculations and verify that in those orbits you have relatively small radiation.
How many PhDs in plasma physics are there in the room? Oh, I'm a PhD in plasma.
We got another one there.
I've worked at Los Alamos, have you?
So it's an incredibly important potential.
Okay, I think I saw another question emerging right there.
Yeah, hi. I actually missed the first part of your presentation, Al, so maybe you covered this. But in terms of transportation of all those materials, I think you said you can't rely on
rumors floating around Silicon Valley about the Starship and the Super Heavy. I think it's on the order of, it's like about $70 a kilogram for launch. And, but you have to believe the most optimistic rumors. Okay?
It might be a bit higher than that, but.
Yeah, it could easily be it could easily be higher. And at that level, you get you get a situation where you can move in for single-digit millions. That's probably as accurate as one can get. I mean, I in the presentations I go, it's this number, but no, the power bars are enormous. And we'll see what it actually is. Maybe this generation won't be good enough. Maybe another generation of launching before you can get away with it. We'll see.
Another question? I see one towards the wall over there.
Dr. Zubrin, you said that we will export information from Mars. What are the advantages of information that we can take from Mars compared to that we can take from the Moon?
Well, the advantage is that you can create a larger civilization on Mars because there is much more materials available there. So that's the look. The most important product you can create is a child. Okay, and and by the way, that's not without risk. Okay, because you could produce the next Hitler, right? But sometimes you got to take a chance. And but the idea is that a Mars colony, to support a substantial population, in particular of technologically adept people, a frontier culture where they're solving all these problems of growing much more productive crops because they're doing greenhouse agriculture, of developing methods of labor-saving machinery, robotics, artificial intelligence to resolve the labor shortage that they will have. It won't be as severe a labor shortage by any stretch as what you might have in a space colony where you have to build your own planet. But but nevertheless, it will be a severe labor shortage compared to anything that exists on Earth in both magnitude of the workforce and diversity of the skills available in the workforce. And these are the sorts of inventions that they will be driven to. If I wanted to come up with a business plan for a Mars colony, okay, to go to Silicon Valley, I would say, we are going to recruit 1,000 crack technologists who are also zealots for space settlement. Okay, so they're going to have the steel in their backbone. Yeah, they're going to be the pilgrims. Okay, and who will go there and are willing to solve these problems, put themselves on the line to solve these problems. Okay, if you look at, well, so the idea is to create a culture of ingenuity that will solve the problems of settlement, and that provides the material base for the settlement.
This here.
I'd like to propose that maybe next year we could do this debate again.
Thinking the same thing.
Yeah,
In the plenary
this is
hall.
fantastic. But I would propose that we add into the consideration one of the fundamental motivations of space settlement, which is human survival. And I think when you look at these different locations, I mean, this is more from like, what's the easiest, what's the quickest, what's the fastest. But the question I asked is, where would I want to live? Would I want to live in an equatorial, would I want my family in an equatorial neo-settlement, which could be destroyed by a can of nails launched by a third world country? And you know, when you put that kind of consideration in there, I think you'll find that Mars rises somewhat, because there's a lot of ways Mars is much safer than the other locations. So I'm just saying there's a little more to this debate than has been covered.
Okay, we got two questions. I see one there, and then we'll have Rand.
Okay, and just to add a little bit of levity to this, I'm just not so sure that a place for mom is on Mars.
Okay, Rand.
Depends on the mom.
Try again, Rand.
What is the point of this debate?
I've been trying to figure that out myself.
I mean, because to me, it's a false choice based on a false premise, which is that somehow there's some collective we is going to decide where the first place is that we go, when in reality, some of us are going to go to Leo, some of us are going to go to Mars, some of us are going to go to the Moon, some of us are going to the asteroids, most of us are going to stay home, because people who want to live on other planets are mutant weirdos. Not that there's anything wrong with that.
Who's a mutant weirdo?
But I don't understand the point of these debates.
Well, the
I agree.
debate is not,
I agree, that's why when I put my charts up, the first thing I said is, I don't know the answer. I don't think anyone does, but we need to listen to each other and explore with open minds. That's how we're gonna get the wisdom, to start picking some of the right ideas. And I think that's the idea of this kind of discussion.
well, the debate, okay, is not one of how do we control the command economy or of NASA or something to choose, because NASA's not gonna do this anyway, okay? But even if it could, this is not what this debate is about. This debate is to try to use the tools of reason and dialogue, and humor, to sort out the problem and to put forth the pros and cons of these destinations for all of you, some of whom I hope will take this data into account when you start your space colony.
Yeah, I mean, it also, it's a forum which you can move your mind, but you have controversy, which this is set up to create controversy. It forces your mind into new areas perhaps you hadn't thought of before. And the other thing is, I had a good time. How about you?
And Joel's welcome to make another one, then we're out of time.
What I would also say is I think that there's something that we as space advocates can do, and that is, especially if we go to a location where there's resources, you know, we need to be growing food, and there's projects that we can do at our level of expertise to be able to look into these issues and develop, you know, demonstration systems, whatnot. There's work in ISRU in terms of metals and machining and these sorts of things. These are something that those of us at this level can do something about. So it makes a difference as to where we think we're going to be heading in the near future as to what those protocols will look like.
So in the last few billion years, there have been a few important events on the surface of the Earth. The first cell, first eukaryotic cell, the development of chordates, brains and spinal columns, fish walking on the land, development of language. And one thing that we know in studying the history of biology and complex systems on the Earth is that they spread to fill their ecosystem, and then and I'm using this word in a biological sense, not in a historical sense, they colonize other areas. That's a term of biological science. It has no negative political connotation. And it is now, the sophistication of life from the Earth has gotten to the point where it's capable of colonizing beyond its current biosphere. And so it's like the spores of Earth will spread the flower of our planet through the solar system. If we can do that successfully, and the only way to do that and sustain a population of 1 trillion people in the next 1,000 years is with asteroidal resources, then humanity, not just humanity, but life from Earth, which is the most impressive thing in the universe, will obtain immortality. Because at that point, we will spread to the stars and galaxies. And that's what we all agree in, that's what we believe in. And we have different approaches, and that's what we're here to discuss. So thank you very much for listening to this panel.